All right, problem 10. Solve the equation and check for extraneous solutions. So we have x to the 1/2 equals 3. How would you go about solving that? Can you just look at it and tell me what the solution is? What do you raise to the 1/2 power to get 3? 9? As a matter of fact, if we take x to the 1/2 equals 3, and we square both sides. When we raise a power to a power, we multiply the exponents. And 1/2 times 2 is 1. So we get x equals 9. And that does check. The square root of 9 is equal to 3. All right, problem 11. The number of females in law continues to show steady increases. Next pause. All right, let's try this again. The number of females in law continues to show steady increases. The number of female lawyers in a certain country can be modeled by the function f of x equals 0.832 times x to the 1.325, where x is the number of years after 1940 and f of x is the number of female lawyers in thousands. What type of function is this? And you're given 5 choices. Is this a root function, a power function, a piecewise defined, a absolute value? No. Do you see the absolute values there? Reciprocal? Nope. So it's either a root or a power function. Which is it? It is a power function. All right, what is f of 25? Well, you can certainly evaluate this function at 25, which is probably what I would do. F of 25 is equal to 0.832 times 25 to the 1.325 power. So I replaced the x with the number 25 so I could evaluate this function. So I'm going to go open up my calculator. Okay, and I'm going to carry out this calculation. 0.832 times 25 to the 1.325. Okay, and we get 59.2098, which I'm going to write down, and then we'll look at how they want us to round it off. 59.2098. And they tell us to round it to the nearest 1,000 as needed. So 1,000th. So to the nearest thousandths mean we're going to round off to this decimal place here. So since the 8 is bigger than 5, we're going to round the 9 up. But when we round the 9 up, we have to round the 0 up. So this is actually gonna be what, 59.210? This means there were how many? 210, I don't know where the one went. This means there were how many female lawyers in the year, what year? Well, this is in thousands. So if we multiply that by 1,000, that will tell us that there are 59,210 female lawyers in what year? This is 25 years after 1940. So 1940 plus 25 would be 1965. So in 1965, there were 59,210 lawyers. How many female lawyers? There will be blank female lawyers in the country in 2040. Well, again, this is just an evaluating the function. The year 2040 is how many years after 1940? Is that 100 years? So you're going to evaluate this function at 100. So we didn't actually have to do any graphing on this particular function. So 0.832 times 100 to the 1.325. So I'm going to go back to my calculator. And I'm going to raise 0.832. Excuse me, I'm going to multiply 0.832 times 100 to the what? 1.325. And I get 371.641. And they do ask me to round this to the nearest whole number, and I do need to multiply this by 1,000. So I'm going to take that and multiply it by 1,000, and I'm going to get 371,641. All right. Problem 12. The revenue in billions of dollars from artificial intelligence for enterprise applications in a country for the years from 2016 through 2025 can be modeled by y equals 0.492 times x to the 1.194, where x is the number of years after 2015. Graph the function for the years from 2015 to 2030. Is the graph increasing or decreasing over this period of time? Is the graph concave up or concave down? Can you tell me if it's concave up or concave down? Is it up, down, up? It's up, and how do you know that? The exponent is 1.194, which is greater than 1, so this would be concave. Okay, what is the revenue in 2038? So let's try graphing this. They say to graph it from the years 2015 to 2030, which would probably have to be either B or D, wouldn't it? Because if this is the number of years after 2015, 2030 minus 2015 is 15 years. So A and B they don't have the correct window. So I'm gonna graph this from 0 to 15 in the X. And what scale are they using? I don't know. I don't know what scale they're using. We'll just leave it at 1. And it looks like the Y is what, from 0 to 5? So that's what I'm going to use to graph this. Okay, so let me share my calculator. Okay, clear out what we have in there. Okay, so I'm going to put in 0.492 times X to the 1.194. And then I'm going to adjust my window to match theirs. So from 0 to 15 in the X. And I'm going to make that scale 1. And what are we going to do from in the Y? 0 to 20 in the Y? And I'm gonna leave that at 5. So that's what they're using. So 0 to 20 with a Y scale of 5. Let me write that down. Okay, so let's hit the graph button. Oops, I saw a scatter plot on. Let me go turn that scatter plot off real quick. That's from the other day, so turn that off. Hit that graph button again. Okay, well, it's definitely, and I probably could have figured this out because I already mentioned it was concave up. It has to be B, doesn't it? I mean, I'm pretty sure I could have looked at that and determined that it has to be that one. The window is correct. And it's concave up. So that's pretty much all I need to figure out. Okay, is that function increasing or decreasing? Is it going up? All power functions go up.
Decreasing.
So it's increasing. Okay. According to the model, the revenue in 2038 will be about, now you could look at the table to determine this, or you can evaluate it. I'm being lazy, and since the table's there, I'm gonna look at the table and then we can evaluate it also. So 2038 is how many years since 2015? Because that is what my model is modeling, the number of years since 2015. Is this 23 years? So I can go look at my table where X is 23, and that will give me the revenue. Okay, so I'm gonna go to my table. And I'm gonna just scroll down to 23. Oops, went too far. And then I am gonna arrow over just so I can see more decimal places. Even though the screen only displays 3 decimal places, my calculator has calculated it to much more than that. So is it 20.790607? I'm gonna write that down. 20.7907. Because I don't know what I'm gonna round it off to yet. Did they tell me what my round off is gonna be? 3 decimal places. So it's gonna be 20.791. Okay, now I could, as I said, evaluate this function at 23. So we could look at y equals 0.492 times 23 to the 1.194, and we should get exactly the same answer. So I'm gonna do that. So I'm gonna take 0.492 times 23 times 23 to the 1.194. Same answer, right? Same answer. So could you just look at the table? Sure. The table gives you y values for particular x's. Alrighty. Piecewise defined functions. For the following function, find the value of A, f of -3, and B, f of 3 if possible. So we have a function being defined in pieces. Let's blow it up a little bit so we can see it. Y equals x squared minus 3 for every value in the domain less than or equal to 0. So if x is 0 or smaller, then we're going to use the first part of this function to evaluate this function. If x is greater than 0, it's x to the third plus 3. So what's f of -3? How would you evaluate that? Put -3 in the top one. Since -3 is less than or equal to 0, we're going to use the first part of this piecewise defined function to evaluate the function at -3. F of -3 is what? 9 minus 3, and yes, -3 squared is +9. So is that 6? What is f of 3? Do we have to use the second part of this function to evaluate f of 3, since 3 is greater than 0? Is that 3 cubed plus 3, is that 30? 3 cubed is 27, 27 plus 3 is 30. All right. Can anybody tell me of those 4 graphs, which is the graph of the absolute value of x? Promise. Let's go graph it. I'm going to show you where to find the absolute value function on your calculator. Do you know where it's at? Does anybody know where it's at? It's in your math menu. You see in your math menu as you move across, the second one to the right is numbers. It's number 1, ABS parentheses. That is absolute value. And when you select that, it does make the absolute value bars. So we're going to grab the absolute value of x. And they're using a window from -15 to +15, -15 to +15. So let's just change the window. It really doesn't matter. We could use a standard window, but we'll use their window. All right. So, not that I need to use a table, because I don't think I do, and if you do. I don't know what to say. What's f of -7? What's the absolute value of -7? What's the absolute value of -7? What's the absolute value of 8? What's the domain of this function? Is there any real number that you can't take the absolute value of it? Honest to goodness, that should be your give me question. All right. Solving an absolute value equation, maybe not a give me. Oh, and we put fractions in here. I'm gonna be yelling at my college. I should probably not record this on Zoom, but I'm gonna be yelling at my college algebra class tomorrow because they can't add fractions. Oh, I didn't bring them with me. Do you have a calculator that will add fractions? Why, yes, you do. Okay, solve the following equation and check graphically. Well, you can if you want to, you don't have to. So how do I find an absolute value equation? To solve an absolute value equation, are we listening? You take the stuff that's inside the absolute value bars. Not the stuff outside, because my pen wants to help me. Take the stuff inside the absolute value bars. What is that? X minus 1/5. You set that equal to the negative constant. That is your constant right there. And you set it equal to the positive. Then you add 1/5 to both sides. You add 1/5 to both sides. Don't change signs. You're doing weird things with signs. Stop doing that. If I'm adding 1/5 to both sides of this equation, over on the right, it's positive. So we get x is 6 plus 1/5. Now I can do that in my head. If you can't, take your calculator out and do it. This is going to be -29/5, and this one's going to be 31/5. -6 is -30/5. -30 plus 1 is -29. 6 is 30/5. 30 plus 1 is 31. All right. Another piecewise defined function. The number of banks in a country for the years 1935 through 2009 is given by the following function. F of x equals 81.3x plus 12,366 if x is less than 90. Where x is the number of years after 1900, it's equal to -376.4x plus 48,689 if x is greater than or equal to 90. So if you're anywhere 1990 below 1990, you're going to use the first part of this function to evaluate the function. If you're after the year 1990, including 1990, you use the second equation. So what's the number of banks in 1970? Well, 1970 is how many years after, I said it's how many years after 1990? Let me erase this. Is that 20 years? 1990, I can't write. I can't write. Try this again, one more time. Why we have erasers. 1990 minus 1970, is that 20? That was way too much work. Okay, so what do we get? Is that going to be the first part? I cheated, I used my phone. So I get 13,992. Okay, how about the second part? The number of banks in 2000, is that 100? Because the year 2000 is 100 years after 19. I made a mistake. I made a mistake. I made a mistake. I made a mistake. Made a mistake. I made a mistake. Made a mistake. Made a mistake. Made a mistake. Does anybody know what that song comes from? Give you extra credit? No? After 1990, 1970 is 70 years after 1900. Is that 70? So is that 18,057? I think I had it right on my paper and then wrote it down wrong when I put it in. Okay, I feel better. Corrected my mistake. So 100, the year 2000 would be 100 years after 1900. So evaluate that at 100. Oops, better use this correct. Got myself all flummoxed, people. 18,057. So 100, I would use the second part, wouldn't I? If x equals 100, that would be the second part of this function that I would use to evaluate. All right, get myself back in gear here. And I get 11,049. Does anyone want to venture a guess of which of these four is the correct graph without actually graphing it? It's not B or C. How do I know that? D. How'd you guess D?
Be honest, if I did this one.
You're correct. Both of these pieces are lines. They are lines. The slope of a line is the number in front of the X. The slope of that first part is 81.3. That is a positive number. So the first part of this graph has to go up. So it cannot be B or C because the first part of the graph is going down. Can't be that. So it's either A or D. But look at how it's defined. Well, if you could. Without that being in the way. The first part of this the first part of the line is for X is less than 90. So at 90, you have to have a hole in the graph. In that first part. The second part is for 90 X is greater than or equal to 90. So that has to be a solid dot on that end, on the left end of that. That has an open circle for the first part of that graph. So it can't be A, it has to be D. And you can certainly graph this, but you're not going to see the solid dots in the holes. You can see the shape of it though. And they do give you the window. So you could graph this. So let's give it a try. Let's graph it. Okay, I am going to graph this using the techniques that we learned last week. So I'm going to put my function in parentheses. Put on my glasses so I can see. So I'm going to put 81.3 plus X plus 12,366. And then close the parentheses. Well, that didn't work. Okay, close the parentheses, use a division symbol, and then open parentheses to tell my calculator I'm going to be graphing this over an interval in the domain. So I'm going to type in X is less than 90, and I get my less than symbol from the test menu, which is above the math menu. Less than is number 5. Okay, then we're going to graph the second part, which is negative 3. Oops, better put in parentheses though. Negative 376.4. X plus 48. 8. 689. Close those parentheses, use a division symbol, open parentheses, and this is where X is greater than or equal to 90. X is greater than or equal to, is that number 4? And what window did they use? They used from 70 to 130. It looks like they use a scale of 10. And from 0 to 25,000. And it looks like the scale is 5,000. So that it does at least eliminate B and C, which I already eliminated. But again, I could look at the table and see that it's not defined for X is 90, the first part of this. So let's look at the table. So you can see, let's do a table set. So like second start, about where this starts. So I can see that after 90, it's not defined. So at 90, it's not defined, the first graph, the blue graph. So there is a hole at 90 because there's an error. And the second graph is defined at 90. So there's a solid dot at 90. So the first graph will be a hole at 90. The second graph is a solid dot. So the table does show me that. Okay. Almost done. And this is something we haven't quite done, but we're gonna go ahead and do it so you can see how it's done, and we'll do it again at 11 o'clock. Find the power function that models the data. We did quadratic functions last week, but let's do a power function. Find a linear function that models the data. We have done that before. To visually determine which function is the better fit for the data. Okay, so I want you to put this data in your calculator. Put X in a list. I'm going to use L1 and L2. So you go ahead and do that, and I'll do that over here on this calculator. And then we'll meet back here in a second. Oops. I guess I'll have to wait for you. What happened here? We have a calculator that's confused. All right, try this again. Okay, so let me share my screen. All right, so I have the data in there. I need to go turn my stat plot back on because I turned it off just a minute ago. I'm gonna go to my stat plots and turn that scatter plot back on. And then I'm gonna go to my zoom window and do a zoom 9. Whenever you're graphing a scatter plot or something of that nature, it's a good idea to do a zoom 9. Okay, that looks less linear to me than it looks like a power function. So let's see if we can't calculate what the power function is. Okay, so I'm going to go back to my stat menu. And I'm going to go over to the calculate menu in my stat menu. And if you look down through here, A, on my calculator, A is a power regression. So I'm going to run a power regression on this. I put my data in L1 and L2. The frequency list should be blank. And I'm going to go ahead and store this in Y1 so that when I graph it, I can actually see what it looks like. So I go to my variables menu, which is just to the left of clear. My Y variables function 1. And then calculate. So the coefficient out in front of that X is 3.655. And the exponent, the power, is B, 1.316. So the power model is 3.655 times X to the 1.316. So I'm going to write that down. Okay, so the next thing I tell you to do, let's go ahead and go look at the graph, by the way. Let's go graph this. That looks fairly close. Okay, now let's go run a linear regression on this. So I'm gonna get out of here, go back in my stat menu to the calculate menu, and we've done this before. Number 4 is our linear regression. Again, L1, L2, and I am going to go ahead and store that regression equation again. I could store it somewhere besides L1. Y1, I could store it in Y2. Why would I want to do that? So I can see both graphs. Okay, so I'm going to go to my variables menu, my Y variables function, and I am going to store that in Y2. Okay, so my linear regression is, the slope is 7.971. I'm going to write that down, 7.971. And my y-intercept is -7.4. Okay, let's go take a look at that. What do you think is a better fit? The blue line or the red line? I think the blue is a little bit better fit also. I think the power function does a little bit better job. And when we go back and look at our data, we can see that our data is not perfectly linear. So let's stop sharing and let's go back and look. Okay, for this to be perfectly linear, each increment in the X direction is 1. But in the Y direction, we got an increment of 5, an increment of 4, an increment of 4, an increment of 10. That's not 4, that's 8. So the Y values are not incrementing at a constant rate. So for this reason, it's not going to be linear, perfectly linear anyway. So what do you think? Which one did we say was a better fit? The power function. So we have 4 choices here. It's going to be A or D, we think. The power function is a better fit because the Y values appear to be increasing more rapidly as X increases, Or is it because the Y values appear to be decreasing at a slower pace as X increases? Do you remember what that graph looked like? What that graph looked like? If it's concave up, that means that's increasing more rapidly. Is that concave up? So which one is it? Is it D? A? It was A, wasn't it? It's A. Okay, last but not least. And we got 3 minutes. I'm being too slow. Put this table in your calculator. We're doing years from 2005. So this would be 0, 5, 10, 15, 20, 25, 30, 35, 40, and 50, 45. I can't subtract. And we got more, don't we? Oops, 50, 55, 60, and 65. So that's what you would put it in your X1, and then you put the GDP in your X2. And then you can run a power model and a quadratic model. And I know it's time, if you need to go ahead, and we'll pick this up at 11. I'll show you the results at 11. I'll go ahead and finish putting this in and we can go over it then. Thank you. So if I have everything in there correctly, I can go ahead and run my quadratic model and my power model. Okay, so I'm gonna go out of here. And I am gonna go ahead and graph this. So I'm going to do, let me clear out what's in the y equals first of all, because we've got those two regression equation from the last problem. And then we're gonna do a zoom stat. Oh, I did something wrong. That doesn't look right. Well, I'll take a look at it and then I'll let you know at 11. That does not look right at all. All right, we'll see you back here at 11.